So yeah, this is going to be a very casual video on coding of uh, a data structure called Linklist. You maybe actually know that. So this is very casual because I'm not a very advanced user of C++. I'm going to implement it on C++ and just going to follow the whatever I have designed, and I didn't prepare anything from previous, so you can get the idea of what I'm going to do is completely going to be on this spot. So yeah, so what is a data structure? Data structure is basically, in computer science, you store data in a fashion. Data, say this is the data, you stored it in a fashion, in such a fashion that whatever work you are going to do, it will help you with efficiency and let you find the data you need with more ease. So in such a fashion you are going to design a structure which is called a data structure. So to get started, let's just give me a very quick example to you. So let's say, uh, if you take the periodic table of chemistry. So the periodic table is basically, you have seen the periodic table how it is. So here starts H1 and then some stuff, H1, then the first row containing the H1, He2. He2 is at the last because this is a noble gas structure. So in that case, if you just going to store the data like this, H1, I'm just giving a visual representation, it's not a visual thing, that's I'm giving a visual representation. Say if you store the elements in a table fashion, this is the tabular fashion. So not in this tabular fashion. Let's say you store it in this tabular fashion. H1 containing one electron, one proton, one neutron, and those. And after that there comes H2, He2, and such that, so on so on. So if you store it like this, there will be very problematic stuff, because there is some stuff called resonance, or I'm not sure, I forget. So the diagonal element should have some kind of same properties. Then the noble gas in the last column, you can identify the noble gas directly by looking at the last column. You can do that in coding, but coding in this tabular fashion, but in visual representation this is the more efficient way. So data structure is just like that. So how you represent data to make your work very efficient and less storage consuming and those stuffs. Okay, so this is the structure. And about linked list. Linked list is a kind of data structure which tackles the problem we have with array. So just let's just go very fast with the brief of linked list. So in linked list, what happens is there something called a unit called a node. Okay, so node is a chunk of data where the stuff is like this. Node, you can say the node is another kind of data structure, because in here you are also structuring the data, how you are storing it. So let's say uh, node is not actually a complete data structure, but yeah, it's kind of a data structure. So in node, let's say there is a stuff called value, where you stores the value you want to contain. In array, whatever happens in a linear fashion is like this. There's an array. This is a contiguous chunk of memory which addresses one by one. Let's say you are making an array of int, so the int size is 4 byte. So it will skip, let's say the starting address is 1000, then the next address is going to be 1004, 1008, 1012, like this. So this is a contiguous memory. So what is the problem with array? The problem with array is, like, you have to predefine the uh, total amount of space you are going to require for that array, right? So whenever you are starting to declare an array, you have to specify the amount of space you are going to need. Let's say I'm going to store 8 integers, so it's going to store 8 integers, right? So int arr 8 integers. So you have to specify this. So let's say in our runtime situation, you might need more space. Let's say one more element you want you need more. So you can't just add that element in here because that's going to throw an error, because the storage you are specifying is 8, so you can only go up to 7, right? So indexing start from 0 to 7. So the if you are allocating storage for 8 specimens, so the element, the index will contain 0 to 7. So if you are trying to put an element on 8, it's going to return an error, out of bound error. Okay, so if I'm not wrong, it's going to return an out of bound error. So yeah, and I'm not very proficient with C++. So what node does is it's going to store the value. You are usually storing it here in array. It's going to store in here, let's say the value. So it's going to be an int, and the next part is going to be an address. Address of what? Address of a node. So this is a node, and the next part of that node contains address of another node. So think of it like a house. So this is node number 1, means house number 1, and this is node number 2, means this is house number 2. So the node address contains the next node's address. So think of it like you are going to your relative's home, and your relative's home contains your home's address. So it's kind of like that. So yeah, the first node contains the second node's address. So this is linked list. You are linking the whole nodes to make a list. So in here the problem is tackled because you don't need to specify the amount of space you need, because you can at any time input another node in here and your list will continue to grow on. So, and one more thing that is a very important thing is the whole thing is going to be stored on heap. Okay, okay, the whole store thing is going to be stored on heap. See, okay, so this is the similar kind of link and node data structure briefs. So let's start with what we need to define those data structure. So the first stuff is node. So its visual representation is just like this. Stored data, what is going to be contained, and the address of next node. Address of next node. Okay. So what should our node have? So node is kind of a class. In you can define it as a class. So in C++, I'm going to define it as a class. So in public statement, we should have a constructor of this node. Constructor of this node. Public statement, we have a constructor where we're going to pass integer. So I'm going to make a node of integer. Okay, so you can make a linked list of anything. Okay, so I'm going to make a linked list of node integer. So int a, so I'm going to pass a value int a. So the constructor will put the value inside the node value, stored value, this value, stored value variable. Now why is this going, the stored value is going to be, it's going to be in a private variable. So I'm going to I'm a kind of typical person who identifies both the private and public stuff differently. You can just store the stored data inside public, and you can access the stored data directly, but I'm going to make a setter and getter function. So because I'm just practicing this myself, and I thought why not make a video about it. So the next stuff is the private stuff. So here it's going to be a stored data private variable. I know my handwriting is kind of very bad, but just put up with me for some time. So this is going to be a stored data. Okay, so stored data variable, and the whole thing, let's say this, the address part is going to be another variable, node star, and the next address, next node address. Okay, and the constructor should have a get uh, get stored data, which is an int return type. It will return stored data. stored data, and the next part is a void which will set the return type, set stored data. In case in future we might need to change the data, so we can just go and use this function set stored data. So it's going to be completely dynamic stuff. Okay, so yeah, so the node is pretty much done. It's just like this, and in here it should be like this. So you can get a get. Oh, one more thing, in constructor we have to set the next node address to be null, because let's say in linked list the last node which is stored is going to point the next node at null. Okay, so always put null at the last storage. So when we are defining a first node, we should always put the null, and next we can change that. So next is a void function which is going to set the next node data value. Okay, and the I'm going to be going on the parameter a bit later, so let's just go with the end setup of this. So sorry, not end. So let's say we can actually access the value of this, so it's going to return a node star. So node star uh, get value of next data, and the value contains this. Okay, so yeah, this is going to return the next data part. Okay, done. So node is pretty much like this. So let's just go into code this whole stuff. I'm switching to my terminal. Okay, one more thing, I'm using WSL because it's going to give me a Linux setup. So by default in Linux, GCC and G++ comes right built into it. So let's just start with that. So if I go there, let's see, let's make our directory, uh, mkdir, let's say data structure, cd data structure, sorry, cd data structure. Okay, we are in. So just to make sure, I'm going to make a git init. Okay, so just so I can push it on GitHub. Okay, so next stuff is, let's get started with here. I'm going to use new vim. Okay, so the first thing is, let's create a main file, main.cpp. Okay, just enter the file and just import the necessary stuffs. Sorry, include IO stream. Okay, okay, and also I'm going to use end main and return 0, though you don't need to put return 0 anymore. So I'm just going to put return 0 for now. So let's say this is it. So I'm going to save and make another file. Also, I'm going to put all the data structure in different files, headers and all those stuffs in different files. So let's make a file of nodes. So if I put node, so my data structure is going to contain node.cpp and another file called node header, so node.h. Okay, so in node.h, what I'm going to do is include sorry, not in node.h, I'm going to call if and if, so it's going to put my debug. Sorry, so I'm not going to put it like this. Say node h, node header, define it, and here I'm going to end the whole thing. So I'm going to sorry, you don't need to put the header end. So, and if this is defined, then define node slash h. Okay, so in here we are going to define the class. So okay, so what does our node class contain actually? So our node contain two things, if you remember. So in private, what we contain is, let's say there was an int value which is the stored data on the node, stored data, and the next one is the node star, which is the uh, next node parameter. So next node address, address. Okay, next node address, and the next up is public. So here the first thing we are going to do is node constructor, which is going to take us value for our stored data. And remember, this is the header file, we don't need to initialize any function, we're just defining it. So in the next part we are going to set a get stored data function, which is going to return a integer type, and the next part is void type set stored data. Okay, so yeah, so this is all to get and set the value of stored data, and we can directly put also the void for set and return. So the first thing it's going to return is node star get next node address is defined, and the next part is void set stored set next node address. Okay, so done. Okay, the one more thing we have to pass in here is node star. Let's remember, next node address next uh, let's say item address, so don't get confused. Next item address. Okay, fine. So we are done with the header function. Oh, one more thing, we have to put an semicolon in here because we are defining a class. So I'm going to save this and go to the previous part and go to the node cpp, include, first of all we have to include the IO stream, input stream, and after that we're going to include our header file node, sorry, not like this, to include it like this, node.h. So it should contain the node file. Yep. One more thing. Okay, so I'm going to split the screen, sorry, split the screen, and gonna open the node a header file on the second part of the screen, and going to minimize the whole screen. Okay, so I'm going to be going to the, hold on, going to be going to the upper part of the screen. I'm going to minimize the screen. Okay, fine. So let's define one by one what we have in the class. So the first thing we have in the class is node. So we have to mention the uh, node name standard, standard namespace. So node, and what this value contains is int value. So in constructor we are passing a value integer. So we are going to pass an integer int value. Okay, so and now we are going to store it in the value section of the node class. Okay, so the first thing we are going to do is node store data. We're going to store the data inside node classes store data function, and inside this I'm going to put the value parameter. Okay, done. And the next step we're going to do is node and then next node address, and going to put the put in here null, sorry, null. Okay, I may be defining it right. Actually, I forget if the null is on lowercase or uppercase. So we'll see. We'll just run it and we'll see what happens. Okay, so the constructor is done. After that, we're going to put the get stored function. So end a node namespace and also the get stored data function. So what it's going to do is it's going to return our saved data. Okay, another part is done. So let's just go with the next part. What we have in the list is void of node set stored data. Okay, so in here what we're going to do is set stored data will store the data inside the value. So I have made a mistake. So what I'm gonna do is I'm going to go in here and just in void stored value we have to pass a value, right? Int value to be stored in the next node. So yeah, I'm going to go there. So okay, okay. What I'm going to do is uh, so in here we're going to pass a value int value. Okay, done. And then we're going to store the value inside this. So node namespace and then the stored data. And after that, we're going to save the value inside this. Okay, done. It's pretty much done. So if you sometime in future we need to change the whole value. Okay, fine. So the next stuff is um, node star. Okay, so node star node double colon get next node address get next node address. Okay, so what I'm going to do is return the address node next address. Okay, this should work. Yeah, it's not giving me any problems. So let's just make some space in here and let's work with the next part. So the next part is set the status of the set node. Set next node address. Okay, so in here we're going to pass a node pointer of the next node. So next item address. Okay, done. So yeah, the next part is done. So in here we have to set the address. So what I'm going to do is nodes start so next node address is equals to next item address. Okay, done. So this is done and I'm going to save this. So our node file is kind of complete. So if I open up my main.cpp in here and let's just close one file at a time, and if I go in main, so okay, so what you can do is let's just forget about testing the node right now. Let's create the linked list, linklist.cpp one and also linklist.h header for one. I'm going to structure this more because this is going to put everything in one place and this is going to make a mess. So I'm going to structure it in my GitHub repository, so you can check out there. So for now let's just make it like this, linklist.h. So what I'm going to do is let's just put linked list in here and let's just add the header of this. Okay, so the same stuff and f and f and linked list. I just forgot, is it called linked list or linked list? So let's just put it like linked list for now. You can put any name you prefer, but I think it's called linked list. D, there is a D, ed or D. Define then linked list dot h, and the next part is class. What do you actually do? Class of linked list, and then define it. Okay, in the next part we're going to endif. Okay, and oh, one more thing, we have to put it like this so we don't get an error. So what does our linked list will contain? Let's just define those pretty quick. Okay, so in here I'm going to set my linked list. So just this is very important part. So see, whatever you want to put in here, it depends on you. Okay, so I want three functionality. First of all, adding a new node inside the linked list. So there must be criteria or requirements you have to fulfill, but right now I'm making my own criteria. You can understand by looking at this. So the first criteria is adding new node at the last position, and we can work on the first position also, but one thing is this. Second is traversing the linked list. Traversing the linked list. Traversing the linked list. Linked list. Okay. So this is another kind of thing, linked list, and deleting a node. Deleting a node. This has three kind of structures. Okay. So let's say in adding a node, we also will contain for the next day. For now, we'll just add a node at the last position and traverse the linked list, and the first criteria would be deleting a node from the last. Okay, so the last part. So adding a node at the last, deleting a node at the last, and also traversing nodes. Okay, traversing, sorry, node, that's not nodes, it's linked list. Traversing the linked list. Okay, so so you know the features now, so let's just work with the structure, how I'm gonna put in all those. So the very basic and minimal way of putting this will be two pointer setups. So the one pointer will be on head and the another pointer will be at tail. So what head means is where the linked list starts, and what tails means is where the linked list is ended. Okay, so right now the last node, it means the last node. Okay, so it's work like this. So yeah, so adding a node to the last position. So what does it mean? Adding a node to the last position, what it means is we're going to create a new node and make that node so that, like, the node previously on the tails address will point to this node, and tail will update itself on this node after that. So this is adding a new node to, when we get to the part you will understand, but right now this is the clean explanation I can give you. The tail part, whatever the tail contains, the node, the next value of the tail will pointing to null right now. So we are going to create a new node which is separated from our linked list, not connected to our linked list, which is going to also point to null. So now we are going to tell our linked list that point out the tail's next address value to the new node, and after it's done pointing to the new node, update the tail to the new address. Okay, so this is adding a new node to the last. What is deleting the last address mean? Deleting the last address means we have to we have to make a pointer. Okay, so just before I'm going to talk about the deleting, let's just talk about the traverse and you can understand. So what is traversal of a linked list? So traversal of linked list means you are going to go to every node that linked list contains and can access all the stuffs that node will contain. Okay, so that is what is called traversing, and you can do that by looping through this. So we are going to create a new pointer at the head position, and after that we are going to traverse the whole linked list. So how? The pointer will update itself with the next node address value of that previous node. So it's pointing at head first, so head's next node value is the next node, so it's going to point at that node. Okay, the next is next, then next is next, and like that. So in deleting we can use this traversing mechanism, right? So we will stop at the last node where we stop last node's previous node. So the node the tail contains the previous node of that. So this is my tail right now, tail part, and this is the previous node of the tail. The next part is addressing to this. Okay, so what I'm gonna tell is, say this is the new pointer which is placing right here. Okay, so I'm going to tell the pointer, see, update this value to null. Okay, update this value to null. Okay, fine. The pointer will update this value to null, and then we will tell that the tail point to this pointer node. Okay, so it's going to work like that. It's going to reference by reference by reference. Okay, so now to implement a linked list, what we actually need. So the private part will contain the head. So let's just not put it on private for now. Let's just put it everything on public. So public will contain the head part, the tail part. The data type of this is going to be node star, and the next data type also going to be node star. Okay, okay. So and the next part is uh, we're going to make a constructor. Constructor will take a value and initialize its first node. Okay, initialize its first node. So its work is done like that. Constructor is done. So now we're going to add a new function on adding add node, node at last, and traverse the node, and also we can contain another thing called int size of the linked list. Size of the linked list going to be kind of confusing. Let's say uh, total elements. Okay, so traversing the linked list, and also the next part is uh, deleting a node from the last. Okay, so this is going to be a very long video, I know that, but from the next part we can just modify it and make a short videos on everything. So let's say a short video on adding a new node, adding a those stuffs and those. Okay, so let's just create the linked list part. Okay, so let's just jump into our linked list. So yeah, here we are, whatever we created. So we're going to make a public statement, and inside this we're going to put our first variable, which is node star head value, and node star tail value. Okay, and now what I'm going to do is let's say the first thing what we have in there was the constructor part. Oh, one more thing I forget to add. I'm going to add an integer called total element present. Total elements present. Let's say present. Remove the present part. Okay, we remove the present part. Okay, one more thing, we have to import the node stuffs in here. So include node dot h. Okay, so this is the node.h file, and what we're going to put is like this, and the constructor, right? This is the constructor sorry, I'm typing constructor. Now it's going to be linked list, and what does it contain? It contain a value, int value. Okay, so this is going to be our constructor. Done. Next part is add element to last. What's going to contain is int, another value, add, sorry, traverse linked list. It's going to contain nothing, and after that delete element from the delete element from last. Okay, so what does it contain? It contain nothing. Okay, so think what's going to be our type of this function. So the first is add element to the last. It's going to be having a void. Traverse links is also going to be have a void, and the delete element from last is going to have also void. So this is functionality stuff, so we're going to put voids in the. So right now I'm putting everything on public. We'll fix that in next videos or the video after that. So inside this, let's just first include our IO stream. Okay, after that let's include what we're gonna include is our linked list dot h, and next after that we're going to include our node dot h file. And what we are going to do is say uh, the first stuff. So let's just split the screen and just go to open a new linked list stuff. It's be going to be on the B side, and so the first stuff you can see is there is the linked list constructor. So hold on, I just switched to, sorry, I just switched to our linked list A. Okay, so in here we're going to have is linked list namespace with this the linked list constructor. It's going to contain an int value. What it's going to do, it's going to initialize a new node. Okay, and set the head and tail to itself. So what we're going to do is say I'm going to make a node first. So node, sorry, node uh, temp. I'm going to name the variable to temp, because we are not going to care about the node anymore after this. So let's just name it fancy, origin node. Okay, so making it fancy. So yeah, basically now what we can say is new node, and we can pass in here a value. So whatever our node had, we can pass a value to here. So the value will contain the value part which we are getting from the previous steps. So yeah, it's there. So now it's not complaining. Okay, so now the next part is we're going to set the head value and the tail value to itself. So the node star will contain the head, which is node slash head will contain the value of what the origin node, right? So the address should be passed like this, origin node. So yeah, it's there, and also the tail needs to be updated. Tail needs to be the same thing. We can just copy and paste it like that, but let's say origin node. Okay, done. So it's here. No viable conversion from node start to node. Okay. Okay. So now that's a bit of problematic part. So what we can do is, yeah, so we can pass it like this, or we can do a separate thing. So what we can do is, let's just do this. We're going to directly pass the value. Yeah. Okay. So let's just make it a pointer also. Okay. And we're not going to address those stuff. Okay, sorry. We don't actually need to specify the head and tail namespace, and also we have to remove this. So now this is okay. So our linked list is ready. So the next part is, and if you remember, the node by default sets its next value to null. So let's just go to the new definition, and let's just split it one more time, and let's just go and open our node.h, and we'll put it on C. Same, we'll go to our first part and going to implement the whole thing. So the first element is add element to the last. You know what we are talked about. Adding element to the last is pretty much easy. Add, hold on, sorry, it's not node, it's going to be linked list, and we're going to put add element to the last in here. Oh, one more thing, I was doing something wrong. Yeah, you can just put it like this, so it's going to by default take head from your linked list. But for me, I usually like stuffs to be completely sorry, completely properly namespaced. Okay, so oh, sorry, one more thing. Yeah, I just forget, because this is not a kind of a variable status, so no, you can't just put linked list. So it will think from where are you taking the linked list, head and tail. It's going to be taken from this linked list. So this is the head and tail properly, like this. Okay, so you can just specify this, I guess, if I'm not wrong, this, and then node, head, head. Yeah, you can do that actually. Okay, so I'm going to do it like this, so that it's not going to contain like this head and this on. Okay, and so on. And after that, let's just completely make a separate thing out of this. So add element to the last, it will contain whatever it is, value. Okay, so stuff will start from here. Add element to the value. So adding element to the value is pretty much easy. So what we're going to do is, we are going to create a new node star, and origin node, not origin node, new node, and we're going to put new node value in here. This is by default going to point at to null, and what we're going to do is, this tail going to this tails value going to be point this tails, how to set this value. So to set this value, we are using set next at node address value. Okay, so what we are going to do is, we are taking the address, we have to remember. So we have to tail, sorry, tail, and set next node address. Okay, so next node address will be at new node. Okay, so I hope I'm not doing wrong thing. This tail, and now the tail will point at new node. Sorry, not point at. It's going to be equals to this. Sorry, it's going to expect me to put this. Okay, so if I put it like this, the next stuff is already the video is going for so long. It's already 45 minutes right now. So I'm sorry, I'm taking a bit too much because I'm not totally completely comfortable with C++. So I'm going to put it like this, and I already said this is going to be a casual stream. So let's just stop right here and just implement to see if we can do this. Oh, one more thing, we can just implement the traversing part. So what I'm going to do is void linked list traverse linked list. Okay, so in here what we can do is we can start traversing from the head part. Okay, so we'll create a new pointer for iterator. We'll call it iterator, and it will take the value of this head. Okay, and after that, one more thing I think I have to do in the linked list origin, we have to increment this dot total elements plus equals to 1. So equals to, we have to first initialize equals to 0, and then we have to initialize it equals to total elements is equals to 1. Sorry, plus plus. Can I put it like this? I hope we can. Yeah, we can put it like this. And every time we add a new node, we are also going to increase the value of that total elements by 1. So plus plus. Okay, so also it is done. Okay, so if I go under there and if I go here, so say we want to traverse the linked list, right? So what I'm going to do is I'm going to make a for int I equals to 0, which is actual the iterator for the for loop, and I is always less than it's always going to be less than this total elements and I plus plus to have this. So what this going to do is, so let's say it's going to traverse to the whole list. So uh, the iterator have head. So what the iterator will do is it will print out sorry, I have to put it like this, cout, and we will iterator, and we will how to print the nodes data. So we are using a get stored value, right? So we are going to use get stored value, and also we are going to use tab after this, so we can see, right? So after this we're going to update the iterator. Iterator equals to iterator equals to uh, iterator get next node address. So it's going to have this, right? Okay, so it should work. Okay, so if I go and save this and go to my main.cpp, and now let's just add the main.cpp here, and I'm going to edit it in this format. So the first thing we need is we need include linked list, right? Linked list, sorry, the linked list file is like this, and we're going to initialize a linked list, sorry, linked list is hello. So let's put it a name, let's give it a trial. Okay, so linked list, and going to give a value of 6. Okay, so what does this trial contain? Trial contains uh, add element. So let's just add element to see if this actually works. So I'm going to put 7 in here. So it's by default giving me a dot. Okay, I'm going to follow whatever it's going to give me. Dot add a new element, and let's add 5 for our convenience. Trial, so by now the trial should have 4 elements, so 8. Okay, so it should have 4 elements. Now what I'm going to do is I'm going to trial, and I'm going to traverse the whole linked list. Okay, so before I do that, let's just quickly open up our node cpp to see if there is any problem with that. So yep, there is a bit of problem that I have caused right now. So this is the node stuff, and this is the next address. So we want to return the data structures stored value, not the node parameters value. So what I'm going to do is this and this. So it should, I just remembered this from doing the linked list stuff, so I just remembered this. So it, oh sorry, I removed something. Okay, so I'm going to quit by default. Okay, so now if I g++, okay, let's first see what we have in here. So we have to put everything together. So g++, the first thing is node.cpp, and after that the linked list dot cpp, and after that the main.cpp. And now if we compile this, yeah, it compiles, and a dot out. Okay, so it's working actually. So we saved 6758, the value in there, and so it's working. So traversing and adding element to the last is done. Deleting isn't there yet, but deleting is very simple. We'll go through that because the video is already very long. So yeah, I'm going to stop right here for now. uh, okay, see ya in the next video. So from the next video it's going to be very short, 4 minute 5 minutes video, where I'm adding a function or 3 to 4 functionalities to add on this stuff. So yeah, see you on that.